Hi, this is Mrs. Vrobel. This is Data Analysis Part 3. So as you can tell, we're going to be covering the following topics here. We're going to be using dimensional analysis. You may have heard the term unit conversion. It's the same thing. We're going from one unit to another. Also, you're going to determine the difference between accuracy and precision. What's the difference between the two? As a result of that, you're going to calculate percent error. And then lastly, you're going to determine what type of graph do you need depending on what your data is. Okay, so dimensional analysis, you've done this before, but you probably didn't realize you were doing it. We're just going from one unit to another. So always make sure when you are doing dimensional analysis that you include a unit because you need to figure out what unit are you converting to. Here I have an example where I have days and I'm essentially converting it into seconds. And notice that the way I arrange the units is I want the desired units on top and I want the unit that I'm canceling out on the bottom. So hours cancel out and days cancel out. And the only thing I should be left with is seconds. And here I just have to multiply across. And then when I multiply across, I get 2.8 times 10 to the 6 seconds. Notice I followed sig figs, and instead of having a million digits, I only have 2 sig figs because of the numbers that I started with. Okay, what is the difference between accuracy and precision? So your book does a really good job of showing you arrows that are being placed into a target. And notice that this person that was using the bows in this target, their arrows are off the mark, okay? Now, because they all center around the same area, we call that precision. So someone could be measuring something in a lab, but they're measuring it incorrectly. And if they keep getting the same number over and over again, we call that precise. Now here we have an example where the person was able to get all the arrows in the target. So we call that accurate. And then obviously the last person, they were all over the place. They were not considered accurate because they didn't hit the target. And then lastly, none of their arrows centered around one location. So accuracy, we're looking at how close is your number to the accepted value, okay? And in lab, you're going to have an accepted value, something that you look up in the book or the internet, and you try to hit that mark. Precision is something different. So precision, we're actually looking at reproducibility. So how likely are you to get the same number twice or close to the same number? Now, error is something that we typically look at an experiment, and notice it's accepted minus experimental, okay? So whenever you're looking at error, you're comparing your experimental with the accepted value. And we will ask you to calculate percent error. Notice that percent error is error divided by accepted value. So it's essentially this. Just bring it down here and you take. So notice that this error value, you're taking the absolute value of it. So it could be negative or positive. And we just take the positive value divided by the accepted value times 100. Okay, so all measurements have errors, but it's important for us to tell the audience how big is our error. And please remember that the last digit in your figure is always going to be subject to error. Here we have an example of student A versus student C, and we're essentially looking at the average compared to the accepted value. Notice that student A's value, is it accurate or precise? The density is 1.59 grams per centimeters cubed. Yeah, I would say that they're accurate and precise because their numbers kind of center around the same values. Okay, graphing. Graphing is really important in science, and I know some students, they either love it or they hate it. Please note that it's important to decide what kind of graph you're going to use. In the past, you've probably used tables. The problem is the tables are very hard to understand what's happening to the data. Now here, someone has chosen a pie chart, and a pie chart typically tells you the percentage of a quantity in the whole piece. Okay, here I have a number of graphs, and please note the bar chart. The bar chart, this is something that students struggle with. Most of the time you will not be doing the bar chart in chemistry. Typically you'll be doing a line graph. And please note with line graphs, okay, whatever's on the x-axis, that is considered the independent variable. So mass is not the independent variable, it's the dependent variable. Same with this graph over here. Elevation, that is considered the independent variable, and temperature is the dependent. Okay, slope of the line. This is another review. You've probably seen this before. So we look at how big is a slope with a line graph, and we typically use that to interpret the data. Please remember that a slope is rise over run, so change in y over change over x. Yes, you will occasionally have to calculate your own slope. Okay, for interpreting graphs, we have what we call interpolation or extrapolation. So what that means is that interpolation, we're looking at the data between points on the graph, and then extrapolation, we're looking at extending the line. So we might use that to potentially predict what's going to happen to something outside of the graph's area, or maybe we're going to use it to predict what's inside the graph's area. Okay, lastly, dimensional analysis, we will use a lot of that. So with dimensional analysis, we're essentially looking at conversion factors, and they will be given to you. You do not need to memorize them. Please note that the difference between accuracy and precision, accuracy, we're looking at accepted value, how close is it to that. Precision, we're looking at the variation of a number. Percent area, we're looking at deviation from the accepted value. And then lastly, independent variables are plotted on the x-axis, not the y-axis, and we can use slopes to extrapolate or interpolate, depending on what we need.